Okay, this is the standard cheapest GE dryer with model number that starts with GTD42EASJ2WW. Does not heat. I have not looked at this yet, so I'm learning this together. No rust, no leakage on the edge. Take that out. I use basically a pair of pliers, screwdriver, and to test for what's wrong with the heater is the OEM or resistor tester. Put it to ohms. I've got it at 20K. Test it on itself. You see it's going to 0.0 something because it's a cheap $7 Harbor Freight machine, but it works. All it tests to make sure is that there is a continuous piece of metal. As you can see on here, it's giving me a reading. It's not the most stable because, again, it's a cheap instrument. It's probably getting a little disconnected. But if you put it on something that's not a piece of metal, it'll give you no reading. One piece of metal combined, you get a reading. First thing with these machines, these cheap GE models, is it's held together on the sides by simply a ridge that it fits into. This one has a screw to take off the back 1/4 inch screw. So I take my drill. You can use hand tool, you can use a drill. As long as you don't over tighten, you're fine. Take out the screw completely, otherwise it will fall out and you'll probably lose it. Put that there. These models have a couple of different ways. One of them is that there is a part that you pull this main top part out and you have to turn it left. This one, you pop that off by a simple towards the rear of the machine pressure, not a lot. And then there's one screw right here on the end. Take that completely out. It just fits into another little screw hole in the bottom that's hard to find later. I put those on a magnet holder. So that's the back of it. What I actually do is put this back on, somewhat pop it back on, and put one of these 1/4 inch screws slightly back in, just so it doesn't fall out. Going back to the flathead screw on the underside, there's only 2 screws on the underside of the top of the dryer. Do not remove any other screws. The rest of the screws hold in the actual what's it called? Plastic frame that it glides on. So you don't want to remove those or else you'll have a mess trying to get those back together. Again, put those back on my magnet holder. So like I said, this is not held on by anything else other than this little raised part meets and fits in a groove, as you can see. So when you put it in later, you just have to find the groove and seat it. I pull it forward a little bit. Oh, it's got one of those guides on the back. This one's fine to just hold like this. A couple variations. I was kind of expecting that to be a little different, but this one, it's got a 1/4 inch bolt nut right there, 1/4 inch on the other side. And when I said that it takes off the plastic part that this glides on, this is entirely plastic. So check out these glides to make sure that they are there and to make sure they're not too thin, because this metal part of the drum glides on these plastic slides This one's not quite seated down, so I'm just pushing on the end of it to try to get it seated better. When you pull them out, there's two major variations. One is you have to pull the screws out individually. Two is it's got a little retention clip. This one has a retention clip. Squeeze where my thumb is making contact. Sorry about the shaking. And it pulls out. This one's easy to break, but it's also hard to disconnect, so take your pick. And this one is a pull apart. Commonly, there's another third one that is simply just pull, and it's a one wire to one wire. Another thing that I do while I'm doing this is clean it out. So there's this stuff right here. This is just the bottom of where the lint trap goes. So as you can see, there's actual lint that is pulled out of the fan area. I run my finger kind of down there. Be careful, it can be sharp. Another part of carefulness is see how the plug is visible. Always make sure that you can see the plug to make sure that it's unplugged. Now that that's disconnected, you can shut the door. To remove, you pull up, and it's again a cut in the sheet metal that's bent slightly up that fits into a raised part. There's no real engineering would be the word I'm looking for. Thinking of. There's no real engineering involved. It's just they cut a hole and they cut a notch and they matched them up to put these together. It's kind of ridiculous. Lean this safely against something. I still have those top 2 1/4-inch screws. Okay, so heating elements in the back. You have to take off the drum. There is one screw here that I take off. And then move this a little out of the way so that this side panel gives me enough room. If your arm is really skinny, then great. And then and this is impossible to show, but you reach in from both sides, grab the belt retention pulley, take the belt off, and release. Now, when you actually get this thing out and off, you can kind of see what I'm talking about. Also, always inspect the belt. Pull it back just a little bit to make sure that there's no cracking that you can visibly see that's becoming a hole. This one, there's either a ball and socket, or it's simply just forced in there. So I'm going to pick up a little bit and pull out, and it moves. Use the belt as the handle. The belt is very, very strong. This one does not have the ball and socket. It simply has a plastic slide that goes over this. Inspect that, make sure it moves, make sure it's not thinned out anywhere. Put the drum in a safe spot. Sometimes, if the drum has a rattle to itself, instead of anything inside, it just keeps rattling. Sometimes things get caught in the baffles that actually help rotate the clothes on the inside. So what you can do is take either, sometimes it's a 1/4-inch head. This is a Phillips. You just take these 3 screws out, which holds that baffle that does the rotating inside the drum. Because sometimes quarters, usually dimes and pennies, can get stuck in here, and they're just floating around that little piece of plastic. So every time it turns, they shake down, then they shake up, they shake down, they shake up, and they just make noise. So this is the tensioner pulley. It is covered in a red grease, so wear gloves. When you take it off, it pulls down, releases tension on the belt. You pull the belt off of the spinning motor pulley on here. Another thing to do, that's how you take the belt off. Another thing to do when you're testing this, sorry about the shaking, is, and here's the red gel all over my thumb that I just got on my phone. Perfect. is make sure this spins freely and continues to spin, because that can cause problems. There's other parts here, but most of the heating element parts are actually in the back. So the heating element heats all these little pieces. So this all has to be one connected piece of wire for it to heat. And this wire is disconnected, which the guy said he worked on it himself, which can explain that. But to test that, you take your ohms reader, multimeter, turn it on. Every time you turn it on, make sure that it works. Touch it to the beginning and the end of the heating element. In this case, it is the purple wire on the very bottom. You touch it to the heating element, and then you touch it to over here, and you can tell it's got a reading. Touch it to the second wire on the bottom left. It should have a reading, or I can just, for illustration purposes, what I'm doing is touching this piece of metal to this piece of metal, and it's giving me a reading. That means that the heating element itself works fine. Now, the little part that's supposed to be hooked up just fell apart in my hand, so that is what went wrong. Let me shine a little light with my drill so I can get a better look as to why it fried. No real clear picture as to why it fried, but the end of it got hot, melted the connection. And to look at the heating element itself, and it is black on that end. So I've got a decision as to whether to sand and clean off the black connection on the heating element itself and try to reconnect while cutting back about an inch or at least a centimeter past where it overheated and got black, or replace the heating element. I'm leaning towards replacing the heating element because I don't know what caused it to arc and overheat there, and that's pretty black on the actual connection. So I'll be replacing this entire heating element, which is incredibly simple. Heating element's held on by those 4 screws in the middle, and correction, that's not the heating element, that's the actual part that the drum slides on. Correction, the 4 screws on the 4 corners of this. There's a screw inside here. This one's and this one are interesting to get to because they're actually inside a quarter size hole, and then this one's super easy to get to because it's right there. So that's what holds on to your heating element. But first, you have to disconnect all of these wires, because otherwise it's just going to hang on by the wires. The other option would be to put up the new heating element, wire it exactly how it is to the new one that matches, and then put the screws on and slide the other one out. It's kind of your call on whether you want to take off all the wires now or later. Always take a photo before we remove all the wires. So let's pretend like I took this off and put it back on. Again, 1/4 inch drive. 1, 2, and so on. Pretending that I did that, and the screw fell in there somewhere. Put this back on. You put the drum in there. You reach your arms underneath to pull this flush and back to give the belt room to slide underneath here, grooves on groove, flat on flat. You know what I mean if you're looking at a belt. Put the drum back in, put this screw back in, put the door back in. By putting it on the glides at this widened angle, or else it won't actually hook and go on. There, I found the groove. Connect your 2 wires. You can't get them wrong. They only match themselves. The other one's a 1 wire. It's literally just a pull apart and push together wire. Make sure that these cords are out of the way when you're connecting it together. Put it up. It will meet, but you have to make it meet so that it's flush. And you actually have things like this piece of metal line up with this slotted hole in order for it to go together. That's how this whole thing is. Put that screw on the top. Same thing with this one. Push it together so that the slotted metal goes together. Put that screw on top. And then when you put this together, you have to make sure that somehow this slotted groove finds this little hole. And to give you a better angle, it goes together, but you have to do the same thing of just manually moving it millimeter by millimeter until it finds this little groove and seats in there. You have to remove gotta grab my drill. So I tilted that and didn't just pull on it. I tilted it using its own pressure against itself. Instead of you just pulling up, you have to take off that little screw you had on there just to keep this from flying off. The reason I do that is because it's just connected with little wires. So the trick I'm showing you is when you take your flathead or your Phillips again and you get the slot lined up on both sides. This one's a little walker jawed, but so you can't just put this back in its hole and be like, oh yeah, I find it. No, there's like an inch gap. So what you're doing is you're trying to meet up with this hole in front of this